wet lab stuff, if you want to participate, which I would think you would, so you get the credit, you get to do it, yes.
We're taking the quiz on Thursday, so.
Yes. We'll take the quiz first. Anyone else? Because test 3 is going to come. Not sure where it's scheduled. All right. We're going to go over a few things that we did before and go on from there. This is your chance to get it straight if you are having difficulty with it. If you were a cell, a normal cell, you would be spending most of your time doing what? What?
Growing.
Growing. What's your life like? What stage in life are you in? Interphase. Okay. If you decide you want to divide, then you would go into mitotic phase. But quite a few cells do not do that. Okay. My understanding is when you're 100 years old, which isn't that far away, don't tell me it isn't, because it isn't that far away. How old will your brain cells be? 100 years old, because you don't make new ones. Now they're working a little bit trying to get you to do that, but the brain is very careful about things like that. It doesn't want to have a bunch of new stuff done wrong. So you're not really making brain cells. Maybe a little bit they're working on trying to get that, but it would be great for strokes. It would be great for that. Or like accidents where you have a spinal injury and you're paralyzed. They've been saying recently that there's some effort being made to help people with spinal injuries. So that would be wonderful, but they haven't gotten quite there yet. There's an intention to do it. Okay? So we're looking at this and saying the pie chart shows you the green is where the cell is most of the time, interphase. Interphase. Okay? And the yellow part is mitotic phase, starting with, which is the first part of mitosis. So mitotic phase begins with mitosis, and mitosis begins with prophase. Okay. At the end of mitosis, now what do you have to do? Divide, yeah, and that's called cytokinesis. So the last part of mitosis was telophase, and then when you split, that's cytokinesis. And that's not mitosis, that's after mitosis. Any questions? Okay, let's say that you are going to divide. That means you have to double stuff. If you're going to divide, you gotta have twice as much so that when you split in two, you have enough for each half. Okay? So where do you do that doubling? Interphase, what subphase? S subphase. Okay? That's where you're going to make double of your DNA. So that means DNA replication will be in the S subphase of interphase. That's right. Any questions?
Page number?
I'm sorry, what?
Page number?
Good question. That's 96.
I have a quick question.
Yes.
Kind of go back to the quiz.
That's fine.
One of the questions was about what's the last phase of mitosis?
It would be cytokinesis. No, it would be telophase.
Okay, but the correct answer on it was like cytokinesis.
was
It may have been the way
it
it
was
was worded.
mitotic phase, not
Yeah,
mitosis.
so you got mitotic phase, which they're confused, that's okay, it's obvious that they sound a lot the same. You have to be so careful because some things do sound a lot alike. I try to explain it in a way that you understand the differences, but it is a lot alike. So now we're looking at something, what's the first thing you do when you look at a picture?
Get oriented.
Get oriented, what in the world are we looking at? DNA doing what? Replicating, okay? And so we see the DNA double helix, the twisted ladder thing. The steps are what? Very good, nitrogenous base pairs. So the blue goes with the red, okay? And the green goes with the yellow, okay? So those are nitrogenous base pairs, okay? And these are nucleotides. So you have to put them together the right way. If you've got a green one, you have to, up here, then you're gonna have to put a yellow one down here. Everybody got that? It's pretty amazing. It's pretty amazing it gets it right, basically, most of the time, not all the time. Now, this is an enzyme, this is a potato, I say. It's an enzyme, DNA polymerase, but so is this. So there are two enzymes that are the same. And over here is an enzyme that says DNA ladder, I'm gonna split you in half, okay? So there is one for that, the book doesn't mention it, it says enzymes on line, but they don't tell you which one. And helicase, I think is what it's called. So we didn't worry about that. But do you understand, you're splitting the DNA into two halves, and then you're building, you have the old half, and then you build a new half. Old half, build a new half. Same enzyme in both cases, same kind of enzyme. Now here's the reason, and I don't know if you got this, I've had people that weren't sure about this. Lagging strand and leading strand. Up here, this enzyme says this is wonderful. I can just zip right along, zip, 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 do this. And it's really fast. This one says, well, you got the easy job because I have to go through and make pieces and then glue them together. That's gonna take me more work, more time, so I don't do it as fast, and they call this the lagging strand for that reason. Everybody got it? It's just going the wrong direction for the enzyme to be functioning very well. You can still do it, and when you're done, you have two identical ladders. Yes?
Does this also happen in the mRNA?
Yeah, that's a good. mRNA is not going to be the same as this because you're not making two ladders the same on both sides. In RNA, you're making half a ladder, a helix. And there are different ways that's done, but it's not exactly the same thing. Okay. I'm not sure exactly how it does. The book, we didn't go into it in the book. But it would be interesting. All this is interesting. Some of it gets deeper than this. But at this point, that's as far as we're going into it. Okay? I can ask you good questions just from this. So we got the idea here. We're making two instead of one, but they're coming out identical. And we're happy. We're happy. And we use the same enzyme in both cases. But in one case, it's going in the direction it likes. And in the other case, it doesn't like this direction, but it has to do it. So it takes it longer, it makes what they call lagging strand. But it's just the same ladder either way. Any questions? Let's talk mitosis for a little bit. And these are beautiful pictures. This is page 100 and 101. Okay, 100 and 101. Now I do have a bone to pick with them. What they entitle this. Mitosis. Do you agree? What's the beginning? Is that mitosis? No, so I would disagree. This is not all mitosis. You have interphase, and it's not part of mitosis. But it's the thing before mitosis. And you have to do the DNA replication in order to go into mitosis, but it's really not mitosis. Mitosis starts with prophase. and they have an early prophase and a late prophase, which is fine, but our book doesn't go into it very much, and we don't. We just say, okay, prophase. So, if you've got a cell like you do here, has this cell decided to divide? This one right here. What do you think? Has the decision been made?
It's growing.
Yeah, what are these two things? Centrosomes, each with 2 centrioles, you would only have one. It only does this when it's getting ready to divide.
Oh, okay, so it's getting ready.
It's getting ready, yeah. And you know, your nucleus has an envelope, nuclear envelope around it, and it's got that nucleolus in there. You remember what that makes? Ribosomal RNA, the rRNA, which you can keep using over and over again. And a number of these things you can use over and over again, which is fine, okay? We see all these wisps in here. This is chromatin. But you see over here, we don't have the chromatin anymore. So there's a change there. Okay, I'll ask you this. How many chromosomes in a normal cell? 20 total, how many? Okay, I better ask this, I don't really want that. How many strands of chromatin in a normal cell? 46, okay? So there are 46 of them here. Except, they end up looking like this. How many of those would you have? You'd think 23. But, what you really have were the 23 strands here in interphase, S subphase, and those 23 strands are going to be doubled, aren't they? And when they're doubled, they don't take off like this, they stay stuck together. And so they are now 2 strands of chromatin stuck together. And where are they stuck together at? Centromere. And so they're stuck at the centromere. One is the original, one is the second one that was made. Okay? And we call them, when they're like that, we call them a pair of sister chromatids. Okay? But the average person would look at that and say, well, that's a chromosome. And they're correct. It is. So you didn't realize that a pair of sister chromatids are actually a chromosome. Now this gets a little messy, so we're not going into all that. All I want you to know is how did you get a pair of sister chromatids?
Duplication of chromatin.
A chromatin got duplicated, but the 2 stayed stuck together. Everybody okay with that? That's where sister chromatids come from, yes.
So we learned that the DNA molecule is wrapped around histones.
Right.
So are the chromatin strands wrapped around histones? Within the nucleus?
That's a good question.
Like each individual strand, and then it
I
unwinds?
think they double without the stones. I think they can always get them back again. So I think that's what happens, but I'm not positive about that. Okay, so here's a pair of sister chromatids, another one, another one, another one. So how many?
23 pairs.
Everybody agree? 46
6 total.
pairs of sister chromatids.
Oh, you 46 pairs?
Yeah, because you made a pair from a strand of chromatin and you had 46 of those. And they just stayed, when it made the new one, it just stayed stuck together, so you have 46 pairs of sister chromatids. I know, this gets a little confusing, like, you have to take it apart and think about it. Do you notice those centrosomes are migrating to the poles? They went to the poles, or they're going to the poles? And what's come along with them?
Spindles?
I wouldn't call these spindles. They're strands. What's the name of the strands? And that's just a shape that looks like a flower. Microtubules, right? So the spindle is made out of microtubules. Okay? These strands, microtubules.
And did you say, sister chromatids are paired chromatin?
That there are, okay, a strand of chromatin has doubled but stayed stuck to the original one.
Okay.
So it's a pair of sister chromatids. Any other questions? All right, look at those little things there. We're in late prophase. We're in prophase, late prophase. But you notice what's missing? Nucleus. What part has disappeared? The nuclear envelope broke down. Why? Because the dance of the chromosomes. You gotta have some floor space if you're gonna dance, don't you? So these chromosomes wanna get out and dance, and the nuclear envelope's in the way. So we got rid of it. Okay, now tell me, they wanna dance, but this dance isn't gonna last a long time. So where are they headed?
To the center.
To the, if you're going to South America, you can cross the.
Equator?
The equator. This is the equator. They're lined up on the equator. Who's lined up on the equator?
Sister chromatid.
Pairs of sister chromatids are. And we got these microtubules still stuck on here. This is when the microtubules look like a football shape that they call the spindle. The mitotic spindle. Okay, is that completed now? Yeah, it is. Okay, so now they're all lined up there. So what would you call this stage? Metaphase. And you'd be correct. Okay, what's shortly gonna happen? The sisters are gonna split apart, say bye-bye, and they're gonna go their separate